Okay, this first page we already did. But again, this is the stuff that you need to know. Okay, I think you already wrote it down, or if you didn't write it down, it's going to be, I'll put these notes in Schoology as well. Okay, but this is the stuff that you need to know for Tuesday. Okay, so let's take a look at a modeling problem where we have a word problem and we need to come up with a solution. All right, so you don't necessarily have to write this one down word for word. Like I said, I'll put these slides on Schoology. Next problem we do, I'm going to give you the worksheet. And we're going to do number 1 together anyway. Okay, so on this one, if you kind of want to just take notes of the work we do, and then you can go back in and fill in the body of the problem if you want later. But I want everybody paying attention rather than trying to speed through writing this down. Campers at an aerospace camp launch rockets on the last day of camp. The path of rocket 1 is modeled by this equation. Negative 16t squared plus 150t plus 1, where t is in seconds, h is in feet. The path of rocket 2 is modeled by this graph. Okay, so this is the graph for rocket 2. They do not give us the graph of rocket 1. Which rocket flew higher? Okay, so height, am I looking at the x value or the y value? The y value. Okay, so let's just analyze this graph. So I can see right there that vertex is going to be my max height. And I'm going to kind of approximate this one. I mean, I'm between 500 and 600, a little bit closer to 600. And so this coordinate is at 6 and about 580, we'll say. All right, so I know rocket 2 flew a height of 580 feet. Okay, but I need to analyze the path of rocket 1. Well, rocket 1 is only given from this formula. Well, I need to find the vertex of this. Okay, how do I find the vertex again? Everybody should say it. Negative b over 2a. Thank you, Landon, for participating. Nobody else said it, but good. Okay, negative b over 2a. All right, so in this one, my x is really my t, because t is over here. Oops. T is over here on the x-axis. And so negative b, so negative 150 all over 2 times a negative 16. So this is negative 150 all over negative 32. When I work this out, I can do it as a decimal, 4.69 seconds. All right, but that does not answer my question yet, because I want to find the height. That only gives me the time it took. So my height, my y value, is represented by h in this function. I'm going to have a negative 16 times 4.69 squared plus 150 times 4.69 plus 1. When I work that out, I end up with 352.56 feet. Okay, so I know my vertex. I know this rocket 1 is going to take a different path. Rocket 1 is going to look something like this, and my vertex now is at 4.69 comma 352.56. Again, this was rocket 2. All right, so now I can answer the question, which rocket flew higher? Well, I can say rocket 2 flew higher. Okay. Which rocket stayed in the air longer? So let's look at flight time. If I want to look at flight time, what was the total flight time of rocket 1? Landon. The one that we worked out there in the red and then the black on the left. So how can we determine which one stayed in the air longer? Eva, what do you say? A little bit louder. Okay, so what specifically are we going to look at? Okay, so how long did it stay in the air? Or tell me how you would figure that out. So what's the 4.69 represent? You're on the right track. Okay, so is that the full time or is that half of the time? Because it takes, okay, Noah, what did he say? Okay, so it took 4.69 seconds to get to its highest point. Well, to go all the way back to the ground, it's going to take another 4.69 seconds. Okay, so we approximate that to 4.7. Okay, so we could do twice 4.69. Let's give it exact. So 4.69 times 2. This one actually flew for 9.38 seconds. From the time it took off till the time it actually hit the ground. Because the Vertex only got me halfway. It took 4.69 to get to that height, but then also I had to go back down, so I'm going to double that. So then rocket 2, I would do 2 times 6, and so this one was actually in the air for 12 seconds. So which rocket stayed in the air longer? This one I could say rocket 2 stayed in the air longer. All right, so let's look at problem number 1 on the application's day 1 worksheets. Okay, not the one with the big black blob on number 1, and we'll talk about that in a minute, but the one that says day 1 at the top of it. So number 1 says the equation h of t equals negative 4.9 t squared plus 25t expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. Okay, so they're giving us our quadratic that we're going to work with. Part A says after approximately how many seconds will the ball hit the ground? Okay, so if we think of this one as a parabola, okay, it's being launched and then it's going to hit the ground. So they're asking us to figure out where it's hitting the ground all the way to the right. Okay, well, we just did one kind of like this. We know that our vertex here will be halfway. So once we figure out the vertex, we can double that x coordinates, and that will give us the full distance of the parabola. Okay, so first thing we got to figure out is going to be the vertex. All right, in this case, they're giving us an h and t again, where t is our x value. And so we're going to do our negative b over 2a to find that coordinate. All right, so this would be a negative 25. Now careful here, this one doesn't even have a c value on it. It only has an a and b, but we only need a and b to find the vertex. So this would be negative 25 all over 2 times negative 4.9. Okay, so negative 25 divided by 2 times the negative 4.9 ends up being 2.55 seconds. So halfway was 2.55 seconds. If I'm going to go the whole distance, I have to double that. Okay, so I'm going to have 2.55 times 2. And that will give me 5.1 seconds. Okay, so how many seconds will the ball hit the ground? And it says it's being launched vertically upward from the ground. So it's telling me it's starting at the ground and it's being shot up. So think of maybe somebody kicked it off the ground. Okay, and it flew in the air for 5.1 seconds before it hit the ground again. Okay. Part B says, well, what will the maximum height be? All right, so again, we had our trajectory going on. We knew this was 2.55. The maximum height is going to occur at the top of our curve. That's our vertex, okay? Should be seeing a recurring pattern here. Vertex, vertex, vertex. We got to find that vertex, okay? So now the maximum height, so I'm trying to figure out the y coordinates. Well, I know my x, which was t, was 2.55. To find the height, that's the same as my y. And so I have negative 4.9, 2.55 squared plus 25 times 2.55. When I work that out, this will end up being 31.89 meters. And in units are important. Okay, if they're asking for a time, pay attention to the context of the problem. Is it in hours? Is it in minutes? Is it in seconds? Is it in days? Is it in months? Also pay attention to units on height. Is it in meters? Is it in feet? Is it in inches? Okay, answers should have units to go along with them for any of these word problems. All right, so the maximum height will be 31.89 meters. Part C says, how long did it take to reach that maximum height? Okay, so we've actually already answered this one. So this one we know this was 2.55. We've already done the work. So now we can simply answer the question. How long did it take? It took 2.55 seconds. Okay, so part A, we did a lot of work. That helped us do part B. C, we didn't have to do any work because we already did the work in part A. So this is 2.55 seconds. And then last, show or check graphically with Desmos. Okay, so this is what I want you doing with your homework. On the actual test, I want to see it done algebraically. So you can see underneath the problem, there's two columns. One says graphically and one says algebraically. All right, let's just do a quick review how we can graph using Desmos. Okay, so you can open up your Chromebooks right now. Let's everybody go to desmos.com. So we go into Desmos. We want to go into the graphing page. Into the left column, we'll put our function in. So in Desmos, you have to do it in X and Y's. You can't do it in any other variable. Okay, so in this case, the function initially was given to us in terms of t. Well, we need to do it in x's. So negative 4.9 x squared plus 25x. You may have to zoom out to be able to see the full curve of your graph. Okay, if it shoots out above your screen, you got to just zoom out a little bit so you can see that full curve. All right, like I said, we can use Desmos to check. Well, I was just giving a quick sketch of the parabola, but in Desmos now, you can literally take your cursor up and it will identify the vertex for you. And so we can see on Desmos, our vertex is at 2.55, comma 31.88. All right, we rounded to 2.55 on its own, and we did 31.89. So this is a check to see that you did the vertex correctly. All right, and I want you checking on this assignment and any quadratics problem that we're doing on a test. Obviously, you won't have your Chromebooks, so you need to be confident enough that you're doing it correctly on the test. But in homework, as practice, check it with Desmos. We can also check down here where it's crossing the x-axis again, all the way up to the right, and you get 5.102. Well, he said it was 5.1. Okay, so 5.1, yep, we did that correctly. Owen. So when it says graphically, just graph it and then identify the vertex and identify the x-intercept. So there's a column that says algebraically, the column says graphically, and the graphically one, draw a sketch of it from Desmos. And identify the vertex and identify the x-intercept past the origin. All right, so again, I want you checking these with Desmos as well. Make sure you're getting the same answer from the Desmos graph as you are from algebraically doing it by solving to find the vertex. All right, any questions with Desmos? You guys all used Desmos before, right? Okay, a little bit? Okay. It's a good tool for graphing, okay? Because our graphing calculators are not going to be used, we'll use Desmos more, but then I won't have you graph on a test necessarily besides a simple sketch. Okay, so let's go back into our notes, so on that worksheet, so I said show graphically with Desmos, so just give me a quick sketch. Show me where the vertex is at, and then show me that x-intercept showing how far it traveled. If you go into the next worksheet, so the one with the big black box on it. Okay, this traditionally would be day 2, but we can do this all together. These flow together nicely. Okay, so the first thing, it's kind of a black blob on your worksheet. It's representing this. I don't know if you can see very well. There's a river going on, and then there's a fence, and the dimensions of the fence. This side is 200 minus 2x, and then this side is just x, and this side is just x. So you might want to just draw a quick sketch if you can't see very well. When it copied it, just copied it as black. Okay, but you might want to just draw a quick sketch so you can see what values are actually in there. Okay, so let's get started here on number 1. I'm not going to finish number 1. I just want to get you started on this one because this one is just like a homework problem that I gave you that you checked here at the start of class. Okay, it says you have 200 feet of fencing to enclose a rectangular plot that borders on a river. You do not need to fence along the river. A says find the length and width of the plot that will maximize the area. All right. What is my formula for area of a rectangle again? Length times width. Okay. And so in this case, if I said that, let's say this side is the length and this side is the width. It doesn't matter. We could have picked either one. But let's say my width is just represented with x and my length is 200 minus 2x. So now my area function is going to be my length, which is 200 minus 2x, times my width, which is just x. Okay, everything we've been doing is with quadratics. Quadratics mean there's something squared in there. Well, this function that we created does not have a square in it yet. It's written in this form. Well, I can distribute the x to each term, and so this would be 200x minus 2x squared. That's the same thing. That's still my area function. then I could even take it one step further to get it more familiar into standard form. It would be a negative 2x squared plus 200x. So all three of those are equivalent. They're just written in different forms and then in standard form. Okay, so this is our function now we're going to work with. This is our quadratic. Okay, question says find the length and the width of the plot that will maximize the area. So I want to come up with a length and a width. I have a quadratic now. In terms of x, I can figure out x, and then from x, I can figure out the length, because the length I know is 200 minus 2x. So that would give me my dimensions. And then part B to your problem says, what is the largest area that can be enclosed? Well, I already know my area formula was that negative 2x squared minus plus 200x. So once I know x, I'll put it back in there, and that will give me my largest area. Okay, so that should get you started on parts A and B on this problem. All right, and that's as far as I'm going to go with it. I want you to finish it up. So for the remainder of the day, all you're going to do is work on those two worksheets. Okay, there's a few problems on the first part, and then there's a few more problems on the second part. Have those done, ready to go for class on Wednesday. During this work time, ask me if you have questions on any of these. Okay, that's what I'm here for. Be able to work through those with you, and so it makes things a little bit easier.